And IF is beta I naught, so minus beta I naught, and same way beta I, because I naught and II are opposite direction. So last circuit, whatever assumptions we have used, same thing. I naught is flowing away from the amplifier, and because of adding an voltage source capital V, I is flowing towards the amplifier. So I naught and I are always opposite. So I can write I naught equal to minus I. I naught equal to minus I. So from the input side, only two currents are there. II plus IF equal to 0. II equal to minus IF. IF, it is beta I naught. So minus beta I naught. I naught, it is minus I. So your II becomes beta I. So this is one expression. And find the current, same formula, whatever we applied, the same thing. So I is equal to, see, one current is at this node, you apply KCL. One current is coming, one current is going down, one current I is coming. So two currents are entering, one current is leaving. One current is AI into II, one current is capital I, one current is leaving. And what is this current through R0? I applied the voltage V, the resistance is R0, so the current is V by R0. So AI II plus I is equal to V by R0, or I is equal to V by R0 minus AI into II. This is one equation which you get when you apply KCL at the output side. This equation you apply KCL at the input side and assume that all the input sources are made 0. Now substitute this II here. So I is equal to V by R0 minus beta into AI into I. So bring this I term here. Okay, so bring this I term to the other side and take out I as common. So I plus beta AI into I equal to V by R0. Take out I as common. I into 1 plus beta AI equal to V by R0, or cross multiply V by I equal to R0 into 1 plus beta AI. V by I is R0 into 1 plus beta AI, and V by I is R0 F. Okay, so V by I is R0 F. So R0 F equal to R0 into 1 plus beta AI. So the output resistance is increasing here because R0 is multiplied by 1 plus beta into AI. The output resistance is increasing. And